On July 1st, 2025, a telescope array in Chile picked up a faint point of light moving across the sky, and it was moving incredibly fast. Astronomers cataloged it as 3I/Atlas. The 3I means interstellar. In the entirety of human history, this is only the third confirmed object to enter our solar system from the space between the stars. The data showed it was traveling at 67 kilometers per second. To put that into perspective, our fastest human-made space probes only reach a fraction of that speed without using the sun's gravity as a slingshot. 3I/Atlas arrived carrying that momentum from somewhere else entirely. It was moving too fast for our sun to capture it. Finding a visitor from another star system is the absolute peak of modern astronomy, but almost immediately, the data coming off the telescopes started breaking every model we have. To understand what went wrong, we have to look at how these discoveries usually happen. In 2017, the very first interstellar object, Oumuamua, passed through. It was tumbling, highly elongated, and completely unusual. The scientific community exploded with debate. Harvard astrophysicist Avi Loeb even published a peer-reviewed paper suggesting Oumuamua could be a fragment of alien technology. People argued. Papers were published. The academic process worked out in the open. 2 years later, the second object arrived, Borisov. This one behaved exactly like a standard comet. It formed a normal dust tail. It validated our existing astronomical models perfectly. Both of those discoveries triggered massive press conferences, open data sharing, and global scientific cooperation. That is the baseline for how we handle interstellar arrivals, and it is exactly what is missing with 3I/Atlas. Within days of the July 2025 detection, telescopes around the world started returning data that defied natural explanation. First, the anti-tail. Normal comets develop tails blowing directly away from the sun. 3I/Atlas developed a third structure pointing straight toward the sun. This is normally an optical illusion caused by Earth's orbit, but teams confirmed the viewing angle could not account for its size. Next, the spectral signature. Known comets are water ice and silicate. 3I/Atlas showed massive, anomalous spikes in nickel and iron. Finally, outgassing behavior. This scatter plot shows normal distances where comets shed gas. 3I/Atlas sits out here, shedding material where it should be frozen. In isolation, any one of these anomalies could theoretically have a highly unusual but entirely natural explanation. Science is built on debating these exact kinds of edge cases. But 3 simultaneous physical deviations in a single object move the situation past a simple curiosity. It leaves us with an impossible dataset that no existing natural model can reconcile. When Oumuamua arrived in 2017, NASA held a major press briefing within a week. 3I/ATS is larger, brighter, and entirely anomalous. Yet there has not been a single official press conference. Major research organizations like the SETI Institute issued one initial statement, then quietly redirected all inquiries to ongoing research that never materialized. The only public updates we get are automated, raw trajectory numbers pumped out by orbital mechanics computers. There is no human analysis. Avi Loeb spent years fiercely defending his technological hypothesis for Oumuamua. He has reviewed the data for 3I/ATS, and he has noticeably declined to apply that same hypothesis here. That kind of restraint from a scientist known for bold claims is a glaring data point on its own. But here is the most concerning detail. In late 2025, the Hubble Space Telescope turned its lenses toward 3I/ATS. Hubble data is almost always made public within weeks. It has been months. The data is sitting in a NASA archive right now. It has not been released. Scientists do not go completely silent when an object is simply a rock. They go silent when the data they are looking at carries implications they are not prepared to explain to the public. For thousands of years, we recorded exactly 0 interstellar visitors. That isn't because they weren't there. It is simply because we lacked the automated sky survey technology to find them in the vastness of space. In 2019, a model from the Harvard-Smithsonian Center for Astrophysics looked at our upgrading technology and made a prediction. By the mid-2020s, we should expect to detect one of these objects roughly every year. We are exactly on schedule. 3 objects in 8 years. This is no longer a fluke. It is a confirmed statistical reality of our solar system. This pattern leaves us with three distinct profiles, one unexplained, one mundane, and one highly anomalous. The sheer variety suggests that the space between stars is far more complex than our current theories allow for. In 1977, a radio telescope picked up a signal from space so intense, the researcher wrote "wow" in the margin of this printout. It was never explained, it was never heard again. It simply faded into history as an unresolved anomaly. We are about to let that happen again. Right now, 3I/Atlas is hurtling past the outer planets, rapidly closing in on the edge of interstellar space. Because of its sheer velocity, launching a physical probe to catch it is impossible. Once it slips past the range of our orbital telescopes, we lose it completely. We don't have to guess what it is. The answers already exist. They are locked in the publicly funded Hubble data sitting on a NASA server right now. The ultimate dread lies in the institutional reaction. We are watching the universe pass by in real time, while the people with the best view have decided to let it happen in total silence.